Hello everyone and welcome to this MacDermid Alpha webinar. Now I would like to introduce today's presenter. With us today we have Avin Doble. Avin is the Global Product Manager at MacDermid Alpha Electronic Solutions. So Avin, welcome to today's event. And with that, I'd like to pass things over to you to get us started.
Hello everyone. Good morning, good afternoon, and good evening, wherever you are based. Welcome to this webinar, where we'll talk about the evolving regulatory landscape in semiconductor manufacturing and delve into how MacDermid Alpha, through its ATROX product line, is providing high-performance, sustainable die-attach solutions. Through this webinar, we hope you will better understand the importance of PFAS regulation and need for PFAS-free materials, and also discover how ATROX provides high-performance solutions to various market segments, be it consumer electronics, wireless or 5G, and automotive. Thanks for joining. Let's begin with introducing ATROX. I'm assuming most, if not all of you in the attendance, are familiar with what is a die attach. But just to set the stage, a die attach material is used to attach a semiconductor die, usually a silicon, to a lead frame or an organic substrate, and is an integral part of the wire bonded packages. Depending on the package design and performance needs, a die attach provides electrical connection, thermal diffusion, and mechanical support to the assembly. ATROX die attach solutions are designed to provide high reliability with products used in automotive space requiring most stringent reliability requirements. Good conductivity, electrical and thermal, as well as good workability across various surfaces. The product line is split into three categories of dispensable paste products. Non-conductive pastes, which are electrically non-conductive materials. These are employed to provide electrical isolation where needed in a given package design. Conductive adhesive pastes, often referred in the industry as epoxy die attach or silver epoxy. This category consists of a portfolio of products ranging in thermal conductivity greater than 1 to up to 20 watt per meter Kelvin and is deployed in standard ICs and power packages. And finally, we have hybrid sinter pastes. These are very high thermal conductivity, upwards of 30 to as high as 210 watt per meter Kelvin products for power packages, usually using GaN and silicon carbide die, and used in a pressureless sintered process, meaning it can be used with the conventional die bonder and box oven cure process without any need for specialized equipment. In this webinar, we will focus mainly on the conductive adhesive portfolio. Like many other industries, semiconductor industry is also grappling with the use of PFAS in many of the products that have been historically used. There have been increasing amount of regulation designed to limit the presence of PFAS, aimed to protect human health and environmental impact from the harmful effects of PFAS. We will spend the next few slides on the very important topic of PFAS regulation and how it is impacting the current and future use of die attach solutions. Okay, so first, what is PFAS? It stands for per and polyfluoroalkyl substances. These have very desirable attributes in terms of thermal stability, chemical resistance, surface energy properties, all of which make them valuable addition to various products used in semiconductor packaging, including die attach adhesives. Next, what are the hazards associated with PFAS? These chemicals are often referred to as forever chemicals due to their resistance to degradation that leads to long-term environmental accumulation. Similarly, there are concerns that they can bioaccumulate in living organisms, including humans, and with links to developmental issues and other health concerns. This obviously leads to occupational hazards for workers that may get exposed to such chemicals. So, the challenge for the industry is to balance high performance, which is derived from the presence of PFAS in die attach adhesives, for example, with growing concern over the hazards and ever-evolving regulatory landscape. Regulatory bodies in EU, EPA in US, as well as those in Asia Pacific countries like Japan and South Korea, etc., are taking increasing stricter measures, which is incentivizing the semiconductor industry to actively and in some cases proactively explore PFAS-free alternatives. Next, let's talk about the basics of a die attach paste formulation. To simplify, it consists of three main ingredients: a base chemistry, which can be epoxy functionality or other types of chemistries, a metal filler, typically silver, to impart conductivity, and then additives, which include but not limited to adhesion promoters, cure promoters to tune cure kinetics, anti-bleed agents to control the flow of the adhesive on the surface it is dispensed on. By appropriate mix of all the above ingredients, one can tune various key properties like modulus, CTE, and conductivity, which all play a critical role in stress management and overall reliability of the assembled package. Now let's talk about use of PFAS in die-attach adhesives. As mentioned earlier, PFAS provides various performance benefits, including thermal and chemical stability, as well as surface characteristics. For example, use of PFAS-containing surfactants to adjust surface energy. Another major avenue for use of PFAS in die-attach adhesives is in anti-bleed agents. These prevent unwanted flow of the resin into areas that can potentially contaminate and cause failures, like wire non-stick on pads during wire bonding and poor adhesion to mold compound, which is used in the final stages of assembly of a package. Suffice to say, using a direct quote from a reference mentioned here, there is a critical need for non-PFAS materials that can also provide adequate performance. Now let's turn our attention to what ATROX offers in terms of PFAS-free materials that also meet high performance standards for various packages. Now, referencing to the earlier slide where we talked about the basic ingredients that would make a typical die-attach paste, ATROX pastes are also formulated using the same key component categories, which includes a paste resin chemistry, a metal filler, and additives. The key difference, however, is that the ATROX products, by virtue of selection of base chemistry, which has inherently no bleed characteristics, there is no need to add anti-bleed agents. If you recall, these are typically PFAS-containing products, which are not needed in ATROX formulations. So in these formulations, the above components are formulated to provide key properties for high functional and reliability performance without causing bleeding on most surfaces. And by the way, no fluoropolymeric components are added intentionally. Now, just for reference sake, let's take a quick look at an example of what a bleed looks like and why it is important. If you can see the image on the left with ATROX product, we see no bleed, whereas on the right is an example what a resin bleed would look like. You can notice the dark, almost like a halo around the dispensed die-attach material. If you look at the image in the center, you can see a zoomed in image of a die attached to a substrate, and the substrate has these pads, the dark square regions that we can see in the image, that are connected with a wire during the wire bonding process. So any bleed of the resin from the adhesive into this essentially keep out zone can cause performance issues during the wire bonding process, especially with wire sticking. So in a nutshell, ATROX products address the urgent need in the industry for PFAS-free alternatives. We also have these products tested by a third-party lab to certify the absence of PFAS in the final product. Okay, now we will talk about the ATROX die-attach portfolio with targeted products designed to meet performance requirements for various different packages, as I mentioned on this table below. Across these products, ATROX offers solutions that have high reliability, suitable for dies of various sizes, from small dies typically at or below 3 by 3 millimeter size to larger dies typically greater than 5 by 5 millimeter. There is also a broad thermal conductivity range from less than 5 watt per meter Kelvin to up to 20 watt per meter Kelvin. Both of our current commercial products, the 558-2C31 as well as the 594ST1, have been qualified for automotive applications, which sets the highest standards for reliability. The two new products that we are commercializing this year offer targeted performance enhancements. So with CD559, we have a multi-surface solution, while with CD570, we offer a mid-thermal solution in scenarios where less than 5 watt per meter Kelvin is not adequate to meet the thermal conductivity requirements for the given package. We'll have some more details on these in the coming slides. In parallel, we are also developing a non-conductive paste with emphasis on lead frame packages. Here we see a need for PFAS-free alternatives that can also address the emerging requirements in the evolving power package designs. With more power, there is even greater need for high-performance non-conductive paste that can provide adequate electrical isolation. Our products will provide high breakdown voltage, which will meet the emerging requirements from the current and new package designs. Over the next few slides, we will go over specific information related to a few of our products to further emphasize high performance potential along with the PFAS-free product offerings. First, let's start with ATROX 558-2C31, which is our pioneer product in our conductive die attach portfolio, with proven high reliability across many package types and surfaces. This includes roughened copper lead frames using our MacDermid Alpha's package bond roughening technology. Here's an example on the right side that shows what we do with this technology. As can be seen with the microscope images on the right, the package bond treatment creates a much rougher surface. This helps to enhance the adhesion of the lead frame to the epoxy molding compound, which is used in the wire bonding process, which in turn provides high reliability in the end package. 558-2C31 has been proven to have good compatibility and bleed control on roughened surfaces like this, as well as bare copper lead surface, as shown on the top two images on the right side of the slide. Besides that, this product also has high performance on BGA organic substrates as well. This provides a unique opportunity for manufacturers to consolidate multiple products that they might be using for different package types and surfaces into a single material, which can also lead to eventually savings for the manufacturing. This slide here showcases some of the performance characteristics of 558-2C31. Here we are showing some moisture sensitivity level, short form MSL reliability data with 558-2C31 on different packages and package types. MSL1 is the highest, most stringent moisture exposure test. 558-2C31 has consistently shown it can meet MSL1 performance requirements on a variety of different packages. It can also be used in large body packages with large dies, where typically you are looking for an MSL3 performance requirement. Speaking about the versatility of this product, 558-2C31 has been demonstrated to have good workability, which provides consistent dispensing on organic BGA substrates. It also provides good fillet formation and die coverage, which are critical to provide adequate protection to the die when it is exposed to stress environment for testing like MSL3 testing on a large die shown in the bottom of the image. Here you can see that after the MSL3 exposure, we see no signs of delamination, which indicates to high reliability. The high reliability with this product is based on performance attributes that includes RBO control, high adhesion to BGA surfaces, no voiding, as well as an ideal modulus that provides adequate stress management in the package. All of this is accomplished through use of unique resin technology combined with a compatible filler technology. In short, it provides a high performance solution that can be used for a variety of different packages. The next product we will talk about is 594ST1, which is our high thermal conductivity product in this category at 20 watt per meter Kelvin. This product has also demonstrated high adhesion to various lead frame surfaces and tight RBA control that provides high reliability. It has excellent workability in terms of fillet height control, die coverage, as well as no voiding. It is especially critical in products like these, which provide high thermal conductivity to provide good dispensability and workability at the same time, considering the high filler loading that they need to achieve the high thermal conductivity. On the right hand side here, we have some MSL data that proves high reliability, where we can see there is no delamination observed after exposure in MSL3 environment. 594HT1 has had a standout performance in terms of RBO control on a variety of surfaces. We have worked with a variety of different customers that have provided surfaces where we have shown and demonstrated that 594HT1 has robust RBO performance. Here's an example on the image below where a customer provided us 4 different surfaces, and we were able to demonstrate that even after 8 hours of dispensing and staging, there was no RBO achieved after cure. On the right hand side here are some SEM cross-section images that show good connection with the die as well as lead frame surfaces, but also good compatibility with the molding components you can see on the bottom right image. These cross-sections have been taken after MSL exposure, showing the robust adhesion performance that leads to good reliability with this product. This product also has desirable attributes like long open time, which provide a wide process window in production environment, as well as low stress in cure state. This is again based on unique resin technology, which provides the necessary surface tension properties for RBO control and also has low outgassing component. It's also critical for high reliability. Our next product, which is ATROX CD559, is what I would call a truly multi-surface solution. It is an enhanced performance version of our earlier product that we discussed, 558-231, but has a much broader compatibility, especially to different die types, including BSM die, where the BSM stands for backside metallization, where a very thin metallization layer is deposited on silicon die for higher performance. Generally speaking, in the industry today, gold is the primary surface used for the BSM die. In the images here, you can see good RBO control with CD559 across 2 different surfaces. We also use this for variety of different die sizes, so it's a multi-die size solution. The RBO is more clearly visible with the dispensed pattern, which is on the left side of each set of image. Most of the die attached materials today work best on specific lead frames, as is demonstrated here with a competitive material on the right side, which has better performance on one type of lead frame, but shows excessive RBO on a different lead frame surface. Here, we take a look at data collected on 4 different lead frame surfaces, comparing CD559 with a competitor die attached product. While the voiding performance is comparable, the key difference can be noticed in the high temperature adhesion data. Adhesion at high temperatures like 260 degrees Celsius provide a good understanding of the robustness of a die attached adhesive and is an indicator of the reliability performance. So as you can see, the competitor material clearly performs better on roughened surfaces, whereas CD559 has similar and high adhesion on all the 4 surfaces that have been tried here. Another noticeable difference can be seen in the failure modes. The failure modes indicates of how the material has failed when the die has been sheared from the substrate. CD559 demonstrates a cohesive failure mode, which indicates good adhesion to both the die and lead frame surfaces that it is attached to. Whereas the competitive material is an adhesive failure mode on non-roughened surfaces, again indicating preferential adhesion to one surface over other, which can have implications during the reliability testing. And finally, here we take a look at the MSL1 data using a gold BSM die and 4 different lead frame surfaces. The data on the right shows before the exposure and after MSL1 exposure, and you're looking for any signs of delamination that indicates failure. As you can see, the CD559 product passes the stringent reliability test on all the 4 surfaces. On the other hand, the competitive material passes only on the rougher surfaces. Now, if you go back to the data that we've discussed and shared earlier, this could be related to poor RBU control, and also poor adhesion at high temperature on some of the surfaces that leads to failures during reliability testing. The high reliability of CD559, especially on different surfaces along with different types of dyes, can be attributed to good RBA control as well as excellent adhesion, as was demonstrated in the earlier slide. These attributes again are built on our unique resin technology and combined with compatible filler technology, as well as also low moisture absorption, which is also an indication of the resin characteristics that we use in our chemistries. The common theme that you have heard across all our products has been the judicious selection of high performance resin systems and matching them up with fillers that provide the necessary property modifications. To summarize, ATROX products offer high performance, and we have seen with various examples that includes good RBO control, production readiness based on good workability, and aspects like long pot life and open times. We have a portfolio of products that provide solutions for multiple surfaces and packages, which meet highest reliability standards. We take advantage of related expertise within different businesses at MacDermid Alpha to provide synergistic solutions like the high performance die attach to go along with the surface structuring treatment for lead frames. And last but definitely not the least is the regulatory compliance with exclusively PFAS-free product offerings. With that, I would like to sincerely thank all of you for your time and attention during this webinar. I hope you found the content very useful and relevant to your specific requirements and need. We look forward to hearing from you, including answering your questions, any questions that you may have. Thank you.
All right, everyone. Thank you so much for listening to our great presentation by Evan. So we are going to move into taking some questions from our audience members at this time. All right. So, Evan, we are going to take our first question here. This person is asking, what makes ATROX different from traditional die attach model or materials?
Good question. And it was covered a little bit in the talk earlier. So essentially, as you heard me saying, most of the conventional die attach materials that have been used in the industry for many, many years now rely on additives, and many of these are PFAS-containing additives that provide the performance benefits, mainly surface characterization, surface characteristics, as well as control over flow, as well as high performance, high temperature performance benefits. What we have done at MacDermid Alpha is we've basically chosen our resin systems which have inbuilt characteristics of flow control, temperature performance, and other performance characteristics that are favorable or desirable in die attach, so that we don't have to rely on adding these additives that almost cover up the performance gaps in the base resin in these currently used die attach materials. So in a nutshell, we have a product that is designed based on very high performance resin systems that provide all the adequate performance requirements that provides high reliability in the final package. So that's the key differentiator between our products and what traditionally you would find today in the market that's been used for several years on the legacy packages.
All right. Thank you so much for that answer. All right. Moving on to the next one in our queue here. Can ATROX be integrated into existing manufacturing processes without major modifications?
Absolutely. It's a total fit-in solution, meaning you can use the traditional and conventional die bonders that have been used in the industry now and for many years, and box oven cure process, or even snap cure. So we have products that fit into both types of cure mechanisms, which is box oven cure as well as a snap oven cure, which actually cures the materials in a relatively low period of time to increase the productivity. So again, it's a directly fit-in solution that you can use in your processes that have been used in the industry for a while.
All right, thank you so much for that answer. All right, next one here. So this person is just saying, thank you for the presentation. And the question is, do we need to conduct what kind of tests in the company instead of environmental stress screening tests, as in cycling, mechanical shock, vibration, etc.? They want to know if it's necessary to evaluate TMA, DMA, etc.
Yes, so very good question. So as part of our data package, we will provide you all the information that is needed to assess the viability and fit of a particular data solution for your package needs. So depending on the stresses that you expect in your packages, which could be driven by the size of the package, the surfaces that you're using in the package. So there are inherent properties of the material. As you pointed out, TMA and DMA gives you an idea of, let's say, modulus and CTE, as well as other properties like moisture absorption, EJ weight loss, which provide you a very good idea of how this material will fit into a package based on some simulation work you may have done to understand the ideal die-attach adhesive that you need. Beyond that, we also provide all the data that comes along in terms of reliability package. So MSL1, thermal cycling, high temperature HAST treatment, and all those things that you typically, there's a suite of tests that you do to stress the package that has been attached with the die-attach adhesive to understand the whole range of performance. So we provide that. We could either assist you in developing that information, or we actually have our applications lab that is fully equipped with all the state-of-the-art equipment. And the way we actually work with our customers is twofold. One is either we develop the data that they feel necessary for them to screen, initial screening, or in many cases, they send us their parts. And using the currently used industry standard equipments, we package those parts and do reliability testing to offer a data package that then demonstrates and proves that our die-attach can work on their specific surfaces and packages, which builds the confidence that a customer may have before they actually bring in our material and test it for themselves. So one of the things that I'd like to emphasize here is a collaborative and a partnership model where we will have very localized experts globally. So we are a global company. So no matter where you are on which part of the world you may be located in, we have experts in that part which will work closely with you, either in communicating the product features, the product performance, or the data package that we generated internally, or work with you to generate targeted and specific data package that may help you to understand what's the right fit and what's the right solution for your package needs.
All right, Evan, thank you so much for that answer. So for our attendees, if you have a question today, feel free to use that Q&A window and enter that in there and click submit. All right, Evan, our next one here. What types of semiconductor applications benefit most from ATROX?
That ranges the whole range actually. So we have solutions that go into automotive applications, industrial, RF applications, power devices, automotive power inverters, motor drives, power modules, consumer applications. So pretty much the whole gamut. And essentially, what we offer is a solution for every need. So depending on the end application, there might be different needs or requirements on reliability, the properties that the die-attach material needs to attain that reliability. So within our portfolio, we have products that will fit the need. And what we do is we work with our customers to identify the right fit and generate the data to support that it is the right fit. And so basically, all levels of reliability requirements in terms of moisture sensitivity level, thermal cycling, and other types of reliability tests that a customer might be interested in. So we have basically one-stop shop for all your needs is how I would answer in short.
Right. Thank you so much for that answer. All right. Next one here. What type of screen testing do you conduct in the product development? Meaning, do you carry out DMA, TMA on all materials or reliability screening testing?
So good question. And I think what we do is there is different levels of screening involved depending on what stage the product is in terms of the development cycle. So initially, just to give you a sense, the way we develop the product is we have a good understanding of the industry needs in general. And we use that to put a specification chart. The specification chart clearly lays out what performance requirements that a new product or a data product needs to meet. And within that, we have different categories where some of the things have to meet. So there has to be a good workability, good dispensability. So irrespective of the properties, if the data product doesn't have good workability, it's not a viable solution. Another important screening technique that we use is the adhesion. The adhesion is a measure of compatibility or applicability of a given die attach for a given surface. And we do both room temperature adhesion as well as high temperature, which was discussed in the slides that we talked about earlier. And high temperature adhesion actually gives you an idea of the performance of the material when it is subjected to subsequent thermal processes that you would expect the material to see during the life of the whole package. So what we're demonstrating is the material can withstand all the thermal cycles or exposure that it will eventually see before the final package is actually assembled. And if you are able to show good adhesion on a given surface at those high temperature, which actually challenges the organic chemistry that you have built the product on, that gives you or builds your confidence in applicability of the product for a given application. So as we progress along and we have met workability, adhesion, then we go on other things like MSL reliability. We do our own thermal cycling testing. And at that point, we also talk to customers and try to understand how well it fits into what they are looking. And if there are things that we are not covering in our testing that the customer would like to see, then we incorporate that in our data package, so to speak, and then offer a full solution data package to begin the conversation with the customer.
All right, Evan, thank you so much for that answer. All right, looking in the queue here, next one. On PFAS, what is the key adhesive property that gets impacted by using non-PFAS materials? How does MacDermid develop products without PFAS?
Yes. So there's a two-part answer to this question. So typically what has happened historically in the industry is that the die-attach adhesive products are developed with certain properties and reliability requirements in mind. But the workability aspect, right? Like I've mentioned in one of the slides, the bleed out, for example, your resin, once it's deposited, it has in some cases, it has a natural tendency for some of the components in the resin system to sort of bleed out of the system. And essentially what happens is those systems actually, the bleed out, if it encroaches in the all important areas where actually you're going to make those wire bonding connections, then you have issues where the connectivity is not good with the wire bonding, as well as when you actually eventually come in and overcoat everything with the epoxy molding compound. Remember, the epoxy molding compound is also interfacing with the die attach. And if there is bleed out zones, naturally that zone becomes a weak point. The way we have worked around this solution is that, and I've emphasized that in the presentation as well, is that you can actually use core resin systems that don't have these bleed out characteristics when they're exposed to either it depends on different surfaces or thermal exposure. So when you heat a particular adhesive, there is no tendency for some components within the system to leach out or bleed out. We have judiciously chosen resin system as our backbone, which not only meet the the modulars, the TMA, DMA, and all the properties that we talked about, but also the flow characteristics that are very important to make sure that you are creating a package where you don't have issues in terms of resin flowing into areas where you don't want to, essentially the keep out zone. So it has been a sort of a conscious effort to build on a backbone that provides performance and control of flow, to then allows us to not be reliant on additives which are added at the back end, right? So essentially, additives are a component in the formulation that you add on top of your base resin, and those are added to provide specific needs or to mask some of the gaps or issues that you may have with the base resin. By using the base resin that actually meets the performance requirements in terms of properties and flow, we are not reliant on adding these additives, and hence we are able to develop a PFAS-free product that also meets the performance requirements.
All right, thank you so much for that answer. All right, moving on to our next one here. On your high thermal adhesive product, I'm curious if it is compatible for snap cure as well. If so, what dye sizes are compatible for snap cure?
Typically what we have seen, and this is something that we can also have follow-up conversations with the interested parties on, because a lot of it depends on specifics of the packages, right? But I'll give you a generic answer. Typically what we have seen with snap cure processes is that customers use this for much smaller dyes, where there's a lot less thermal mass, so you say dyes less than 3 by 3 millimeters or so. So typically what you can do there, instead of having the package go through a box O1 cure process where it's a batch process, where you once package it or dye bond it, and industry standard temperature is a 175 C for anywhere between, say, 30 minutes to an hour. That's the industry standard. But it's a smaller dye, much less thermal mass to cure. That said, your inherent chemistry should be capable of snap cure. So it's not like you can take any chemistry and say, I'm just going to snap cure on a smaller dye because the thermal mass is less. Your chemistry has to have the capability. So our chemistry base has capability to snap cure. And typically what we have seen customers use snap cure is for smaller packages with dyes which are less than 3 by 3 millimeter.
All right, thank you so much, Evan. So next question in the queue here. You mentioned about roughened surfaces. Can you tell more about if MAES tested the dye attach adhesives for EBO, and how is it controlled with your dye attach?
Yes, so what we do is we essentially, when we sort of understand the performance scope of our products, right? So we expose it to various surfaces, and that includes roughened and non-roughened. We understand very well that there are various factors that our customers use while designing a package, and in some cases they may want to use roughened surfaces for mainly it's for enhanced reliability and adhesion to mold compound. But also sometimes they may not feel the need to use roughened surfaces and use bare surfaces, and there could be cost consideration there as well. So we basically test our materials on both roughened and non-roughened, and as I've mentioned in the presentation, both are, so to point out particular products, CD559 as well as 558-2631, we have seen that it performs very well on both the surfaces. In terms of how we assess EBO, it's typically a visual test where you dispense a pattern, and essentially EBO can happen at two instances. One is instantly as a reaction to the dispensed material on a surface. So depending on the surface characteristics and surface energy that you're dispensing a material on, and how is the interaction of your chemistry to that surface, in some cases you can instantly start to see material leaching out or showing a bleed out. And you can capture that with high resolution microscope images. In some cases, this happens as when the thermal cure is triggered. So when you dispense a dispense pattern, you may not necessarily see anything come out, but as soon as you provide heat as a function and a combination of heat and the surface characteristics of the surface that you're depositing on, you might see materials come out. And there is an example in one of the slides of how a bleed out may look like. So we look at the bleed out both as dispensed and as cure, and both as in a dispensing pattern where we probably go for anywhere from a dot to actually a star-shaped pattern or any other pattern that makes sense, as well as we actually attach a die. So place a die on top of the surface and look at the bleed out characteristics around the edge of the die, right? So we do that in multiple different ways, both instantly as is dispensed, and in some cases also. So one example I showed you with the 590 product was we actually dispensed the material, kept it for as much as 8 hours. It shows you the long process window of the material. So essentially, if you were to use that material anywhere in between that process window of 8 hours after dispensing, the material will still give you the performance that you need. And then you dispense the die and actually look for either dispense the die or just look at is there a EBO happening right after dispense or after thermal cure.
All right, thank you so much for that answer. All right, looking in the queue here, this next one, you mentioned about BGA. How different is the die attached composition for BGA versus, say, a lead frame surface?
Yeah, good question. So I think essentially it boils down to stress management and stress mitigation. BGA surfaces, as you know, typically the packages are bigger, the die sizes are bigger. There is difference in CTEs, organic surface versus a lead frame surface. So basically, the way we have sort of addressed this challenge is to fine tune the modulus. For example, that's the easiest way to explain this. Modulus is a very good indicator of how your material is managing the stress that's developed in the package. So essentially, it's a measure of the stiffness of the material once it's cured. And whatever, for example, the BGA packages may have tendency to warp because of the size and also the exposures that it's exposed to in terms of thermal temperature exposure. So as your material or package may have tendency to go through these thermal exposures or thermal cycling, for example, where we are cycling from a low temperature to high temperature and back and forth, moisture exposure, organic substrates may have more tendency to absorb moisture inherently. So you need to have chemistries that are resistant to picking up that moisture and then affecting the properties. So you find the right balance where your material has the adequate moisture resistance, so it doesn't pick up moisture, and the modulus is tuned in that range where any of the stresses that the package may experience, and there will be different stresses between a lead frame and BGA, that it can actually mitigate those stresses. And that's how, for 582C31, for example, we have seen that it sort of strikes that balance where you don't have a material that's so stiff that, yeah, it might still work on lead frame maybe on particular packages, but on BGAs, it might just be too stiff to sort of mitigate the stresses that package might see. And so we have achieved that fine balance, and that what makes it a multi-surface package and a versatile package to be used both on lead frames as well as on BGAs.
All right, Evan, thank you so much for that answer. So for all of our audience members, if you do have any last minute questions, feel free to enter those in now. Or if you have any that you think of after today's webinar, you can always come back during our on-demand period and ask any questions during the 90 days as well. As I mentioned earlier, we will also provide a PDF version of this presentation in the resource widget that will get loaded into the webinar console following the conclusion of today's webinar. All right, so at the queue here, we do not have any other questions coming in at the moment, but we can take a few seconds just in case anybody does have any last minute questions. So we'll give everybody another 30 seconds or so to ask any questions that they might have, Evan.
Yep.
All right, perfect. And as I mentioned, you can always come back and watch this webinar again later, and there is going to be a survey that pops up on your screen that will You can enter in the answers to that during the end of this webinar, or if you're watching it on demand and you come back and watch this again during our 90 days, you can always fill out the survey during that time as well. It's right along the bottom of our attendee console in the survey widget. All right, we'll give everybody a couple more seconds just to see if we get any last questions coming in the queue here.
Yeah, as you are all maybe pondering on the question or what has been discussed, one last thought is that it's, there might be questions in your mind about PFAS regulations and the impact and maybe even the timeline. What we can say is, and what we have seen is, it's not a question of if, it's a question of when, and in some cases it's question of right now and very soon, right? So what we are offering is, and this is always a challenge when there is a regulatory inflection, right? How do we actually change to products that are compliant with regulation while actually also meeting the performance requirements with materials that have already been in the market for some time, right? So there's always this challenge, okay, how do we make that shift? And we are here, we have charted this sort of balance where we have, like as we mentioned before, we have developed product with compliance as a center core piece of our innovation, and saying that while you can actually meet the performance need, you can actually be ready and in a way future-proof your products. Imagine a situation where regulatory bodies come down hard in very soon, in a matter of months or years. By being proactive in changing to a PFAS-free high-performance solution, you are future-proofing your products, avoiding potential supply chain disruptions, right? Essentially, you're not then working in a sort of a much tighter timeline, because now the regulation will call for you to change. So what we are offering is, at the very least, we would like to have a conversation on where you stand with your PFAS implementation, PFAS-free implementation, what are your requirements, and how can we come in and sort of support you and provide a solution that fits your needs, first of all, but also gets you to a point where you have a compliant solution that also works. So you don't have to be actually be in that aggressive timeline or have to do it in next few months or in a year or so. So we want you to be aware that this is a question of when, if not if. And anyway, are there any more questions, Katie, coming along?
So nothing coming in at this exact moment, Evan. So I think we can start to wrap things up. But as I mentioned, it's possible to get more questions during our on-demand period. So if anybody does think of a question after today, feel free to come back in here and enter it in, and Evan will get back to you. So I want to say a huge thank you, Evan, for a great presentation and for such a great Q&A session. So thank you so much for being here.
Right. Thank you. Take care, everybody.
Take care, everybody, and we will speak with all of you soon.